Some of the biggest challenges facing the marine ecosystems at the moment are a huge amount of man-made infrastructure going in. Oil and gas platforms, offshore renewables, subsea telecoms cables. All of this infrastructure encroaches into the marine environment, and so there's a really good opportunity to have these as enhancing structures rather than damaging structures. ARC Marine is an eco-engineering company which is focused on accelerating reef creation on a global scale. ARC Marine bridges the gap between marine conservation and offshore infrastructure, and it does that by designing, manufacturing, deploying and monitoring nature-based solutions. ARC Marine was founded by a group of recreational divers who really wanted to accelerate reef creation on a scale that had never been seen. And so we're really on this mission to find every single way to enhance marine ecosystems where possible. And we think there's a really good opportunity around offshore infrastructure because of the sheer scale of how we build out in the open water. The long-term vision for ARC Marine has always to be a global company. We've already deployed reef cubes into 12 different countries. And that's just the start. We want to hit every corner of the globe.
So we're in Torquay, which is our head office in the south coast of Devon in the UK. We also have a manufacturing facility down in Cornwall. It's really good to be located here in Devon, where we've got access to coastal testing areas and also the southwest facilities. Research and development is really important to ARC and is really at the core of what we do. We use a lot of different techniques, software packages like Orcaflex and Tekla, doing structural analysis and hydrodynamic analysis. So the facilities that we've got here in Torquay really allow us to do complex simulations and modelling of our products and services. We can also do prototyping of our different designs and our products as well through the use of 3D printing. So within the RESP project, we did a lot of work on the stability modelling of the products to make sure that they're stable on the seafloor, starting from computer simulations using Orcaflex and then working through the design process for testing at HR Wallingford to validate the stability. So today we're at HR Wallingford. We're doing testing in one of their basins for our Scour Protection system. So testing is a really important part of our development process to validate our designs ready for deployment on site. Testing here looks at third-party verification for our designs. With the sort of expertise that HR Wallingford have on site, it's another pair of eyes on our technology and enables us to verify our designs ready for deployment.
So the test that we're putting the ARC Marine Reef Cube through is to check the stability of the unit on the seabed to make sure that it will provide the scour protection that they're looking for.
Here in the basin we're testing at 1:31 scale, so we've got the monopile set up with our scaled reef cubes behind us.
So these model cubes have been made out of injection moulded plastic. The density has been changed to make sure that they move to match when the real reef cubes would move, but under our scaled wave.
So the wave paddles here, they operate forwards and backwards. They create a spectrum of waves which matches the sort of waves which we find on site. And then within the flume here, we have a current and a wave condition which is generated representing the conditions of the 50-year storm condition which we'll have on site.
The testing process starts with us building a representative bathymetry. We bring in the monopile and we build the scour protection system using the reef cubes. Then we run a series of storm conditions that are increasing in severity. Once we finish that storm sequence, we then drain down, take photographs to give us that final picture as to how that scour protection system has performed.
So overall for the project, reef cubes providing many benefits in terms of carbon saving, ecological impact and also performance for the scour protection system on site.
We're going to do some filming here. If you see us, don't run us over. The manufacturing process involves taking 98% recycled materials, combining them through our mixing process, and then making the reef cubes that you see behind me. Our production methodology is created around a reef cube in a box process, where we can take all of our materials and the machinery required to manufacture our products. We can pack them up, load them into containers, and then manufacture locally on site to reduce the carbon footprint even further. We're down here at AMP in Falmouth and we're transporting all of our reef cubes from our Truro manufacturing facility down to dockside, ready for loading onto the vessel. So the reef cubes are part of a pilot project that we have for the Reef Enhanced Scour Protection project, or RESP project. So the rough surface texture that we have on the outside of the reef cubes will allow for marine life to adhere onto the structures themselves, further increasing biodiversity. 98% of our materials are recycled sand and aggregate that we can source locally to ensure that there's no plastic being entered into the marine environment.
Offshore wind has the power to do more than generate energy. It can bring life back to the ocean. With RWE Offshore Wind, reef cubes are stabilizing infrastructure and creating 25,000 square meters of habitat through the deployment of 75,000 reef cubes, equivalent to 4 football pitches. It is the world's first nature-inclusive design subsea protection system, converting construction sites into thriving ecosystems, home to a variety of marine life. Where engineering meets ecology, every reef cube becomes its own ecosystem. ARC Marine make restoration scalable. This is how offshore energy infrastructure creates environmental gain. Now imagine if every marine structure had this globally. By 2040, 2 billion reef cubes could be installed around offshore energy infrastructure, creating 750 million square meters of ocean habitat, equivalent to 100,000 football pitches. No other industry can restore ocean life like offshore energy. This is where infrastructure can deliver environmental gain and create the largest reef network on the planet, restoring ocean life at a scale the world has never seen.
We're doing some scientific research at Rampion Offshore Wind Farm. The purpose of the research is to lay down a baseline before we trial our new reef cubes at one of the turbines at Rampion. So the reef cubes are going to enhance the biodiversity around one of the turbines here. We've designed them specifically to try to improve the abundance and diversity of fish and also the abundance and diversity of encrusting animals that are going to grow on the structures. So we've been developing reef cubes for the last 7 years at least for this purpose. So we've developed a lot of science in that time. We use a low carbon concrete and we use scientifically backed habitat features in our designs. So the benefits of reef cubes over standard scour protection is that ours offer gaps and holes and crevices and specifically applied textures on the outside of the cubes, and that provides a habitat for organisms to thrive. The purpose of scour protection is to protect the foundation against scour. Scour is when the tide washes away sediment and it can affect the foundations in terms of their structural strength. So scour protection is applied to prevent that scour from occurring. It basically stops the sediment from washing away and keeps the foundation strong. So we're using a variety of really cool methods here. We're taking water and sediment samples to be analysed for environmental DNA. We're taking video samples, pictures, and we're also taking overnight samples with a light trap, which will give us an idea of the small creepy crawlies that are on the seafloor. I personally enjoyed seeing a conger eel attracted to our bait. We've also seen a black sea bream, which is really cool, and quite a few shoals of fish. There's been a historic trend in the last 100 to 200 years at least of biodiversity declining in the marine space, and that includes the destruction of habitats. So what's important about this project is that it represents an opportunity to build up that habitat complexity and try and build up biodiversity whilst also generating clean energy. There's been a lot of exciting moments in this project. The team and I have worked really hard to develop the methods that we're using here, and to see the data and the samples coming out of that now is amazing. This is a 1 to 10 scale model of our RC350 unit that's going down at Rampion. So as you can see, it's got holes in each face, and then it also has a chamber in the middle. And what that does is it creates space for refuge for mobile fauna like crabs and small fishes. And it also has a roughened complex texture on the outside that allows larvae of epifauna to settle on the outside to build up the natural biogenic reef. The deployment vessel arriving on site to Rampion, it's going to do some surveys in preparation of the deployment, and then it will be deploying our reef cubes around the turbine J04, which is our research turbine. Imagine like scaffolding, you have these bins interlined and material can be offloaded down the scaffold. It's a similar process where you have this connected fall pipe, and it's going to load all of the reef cubes onto a conveyor belt and then offload them down the fall pipe onto the sea floor in a controlled manner. And what we're going to end up with is this kind of dome-like disc around the turbine with all of these spaces integrated into it. What's interesting is that it's going to perform 2 functions. So it's going to perform an engineering function for the turbine and for Rampion Offshore Wind, but it's also going to perform a function for research and ecology. And that's really what our job is about, is integrating those two elements.
What I'm particularly excited about is a 3-year project which stemmed from a 7-year dream coming to fruition, being able to actually point to it and say, look what we've managed to do, we achieved it, and then we just wait for what the future holds on how far it goes.